Hi everyone. So in this session, we are going to solve some questions on pigeonhole principle. Okay. So in the previous lectures, we have seen what is pigeonhole principle. Also, we have seen the generalized pigeonhole principle. In this lecture, we are going to solve some GATE exam questions and some more practice questions from Kenneth Rosen we are going to solve. Okay. So let's start. So let's see this GATE exam question, GATE Computer Science 2005 question. So tell me, what is the answer for this question? See, look at this question. Let me tell you, this same question is also there in the Kenneth Rosen. So you can see this same question you can find in the Kenneth Rosen also. So we will solve both of these. Okay, we will solve this GATE question also, and we will also solve this Kenneth Rosen question. But before solving these questions, we are going to solve some variations, some small variations we are going to solve, and then we will come back to these questions. Okay, is this clear? So before solving these, I will give you some variations, some simple variations we will see, and then we will come back to this question. Now remember one more thing. In the pigeonhole principle, I told you one thing, that if the question is asking for guarantee of event X, then what you will do? Tell me. If the question is asking guarantee of event X, then the best way to solve that is try to prevent event X from happening. So read this. This is very important. We are going to use it. The best way to solve question which is asking for guarantee of event X, that is try to prevent event X from happening. So this is the simple point. Okay. Now let's solve. Now let's solve this question. Okay. But before this, as I told you, I will take some variations, and those variations we are going to solve. So in this question, let me remove this. Okay. Now let's solve this question. Okay. See, very simple. Let me remove the options also. Now let's solve this question. So let's see this one first. So try this one. The question is saying, what is the minimum number of ordered pairs of non-negative numbers? Consider non-negative integers. Okay, non-negative integers, that simply means whole numbers. Okay, you can consider whole numbers 0, 1, 2, and so on. So the question is saying, what is the minimum number of ordered pairs of non-negative integers that should be chosen to ensure? We want to ensure. To ensure means to guarantee. We want to guarantee that there are two pairs, this A, B, C, D, such that A is congruent to C mod 3. First of all, what it means? Tell me. This means A is congruent to C mod 3. This is the symbol. This is the congruence symbol, right? This symbol, what this is called? This is the congruence. This is congruent to symbol. Okay, so you can see A is congruent to C modulo 3. So this is your congruent to symbol. Now, what this actually means? This simply means that when you divide A by 3, then the remainder is same as when you divide B by 3. Okay, this is the point. When you divide A by 3, the remainder will be same as when you divide B by 3. So the remainder is same. For example, you can see, tell me one thing, can I say 5 is congruent to 11? Can I say 5 is congruent to 11? Yes, I can say, because if you divide this by 3, then the remainder will be 2. If you divide this by 3, then the remainder will be 2. So you can actually say that, yes, they are congruent to each other. See, very simple point. I am saying that if you look at this, 5 is congruent to 11 mod 3. This statement is correct. Why this statement is correct? Because if you divide 5 by 3, then what value you will get? When you divide 5, when you divide this 5 by 3, then the value you will get is 2. Remainder you will get is 2. And when you divide this 11 by 3, then also the remainder you will get is 2. They are same. So that is the reason. Okay. So remember, very simple point. This symbol simply means what this simply means. This simply means that if you divide 5 by 3, then the remainder will be same as if you divide 11 by 3. And that is correct. This value is also 2, and this value is also 2. So they are same. Tell me one more thing. Can I say that 7 is congruent to 14 mod 3? Can I say 7 is congruent to 14 mod 3? Yes, this is also correct. Because if you divide this by 3, then the remainder will be 1. If you divide this by 3, then remainder will be actually 2. Sorry, this statement is actually not correct. Okay, this statement is not correct, because See, if you divide 7 by 3, the remainder will be 1. If you divide 14 by 3, then the remainder will be 2. So I can say, what I can say 7 is not congruent to 14 mod 3. So this is the simple point you already know. Now let's come back to this question. The question is saying that you need to make sure, first of all, what you want ordered pairs. You want ordered pairs of non-negative integers. This is what you want. Ordered pairs of non-negative integers. Okay. And the question is asking minimum how many I should choose. Okay. You want ordered pairs. Remember, you want ordered pairs. This type of pairs you want. You want A, B, C, D. This type of pairs you want. And the question is saying minimum how many should I choose? Minimum how many should I choose? Okay. Minimum how many should we choose? Should we choose to guarantee, to ensure? This is important point. We want to guarantee, remember, we want to ensure that what happens, that A is congruent to B mod 3. This happens, we want to guarantee this. Okay, we want to guarantee that this happens. So tell me, how many ordered pairs should I choose? Minimum to guarantee, remember, to guarantee minimum how many should we choose such that we can get this type of situation. Now let's see the answer for this question. See, one more. Tell me, can I say 2 ordered pairs will guarantee? Can I say 2 ordered pairs will guarantee? Can I say 2 ordered pairs will guarantee? With 2 ordered pairs, can you guarantee? Let's assume you say yes. Okay. With 2 ordered pairs, can you guarantee with the 2 ordered pairs? Let's assume you say yes. Let's assume. Then what I will do? Tell me what I will do. If you say that with 2 ordered pairs, you can guarantee this type of situation. With 2 ordered pairs, you can guarantee that A, this is C. Okay. Can you guarantee with 2 ordered pairs? Can you guarantee that A is congruent to C modulo 3 with 2 ordered pairs? Can you guarantee? If you say that you can guarantee, then what I will do, I will give you this type of situation where, for example, I will make sure that you don't get same remainder when you divide by 3. For example, what I will do, I will give you 3 by 5. Okay, only this number matters because we only care about this, that A should be congruent to C modulo 3. So what I will do, I will give you 3 here, so that, because this 3 is basically what? This simply means remainder is 0. And here I will give you 4. Okay. So are you getting my point? What I have done? With the 2 ordered pairs, you cannot guarantee, because what I have done, can you notice what I have done? This simply means in terms of remainder, because we only care about the remainder. Do you agree with me? Do you care about this number? Do you care about this number, or do you care about this remainder? You only care about the remainder. When you divide this A by 3, then the remainder must be same as when you divide this C by 3. Okay, is this clear? When I divide this A by 3, the remainder must be same as when I divide this C by 3. So only the remainder you care about. So this pair, I can simply say it's like I can say the remainder 0, some number. Okay, here I can say the remainder 1, some number. You can notice they are not congruent. You can see 3, 4, they are not congruent to each other. 3, 4, they are not congruent to modulo 3. Okay, because you can notice when you divide by 3, the remainder is different. So with 2 ordered pairs, we cannot guarantee. Very simple point. We cannot guarantee. There is no guarantee. We cannot guarantee. We cannot guarantee. Tell me one more thing. With 2 ordered pairs, let's assume someone is saying that, sir, I can take 2 ordered pairs. I can take this type of 2 ordered pairs. For example, I can take 3, 5 and I can take 6, 5. I can take this type of ordered pair. Now here you can notice this is your A, this is your B, this is your A, this is your C. Here you can notice A is congruent to C mod 3. So can I say that this answer is correct? Can I say this answer is correct? That with 2 ordered pairs you can guarantee? Can I say this answer is correct? Can I say this answer is correct? That with 2 ordered pairs, you can guarantee? The answer is no. See, this is a possibility. This is just a possibility. This is not a guarantee. This is just a possibility. This is just a possibility. This is not a guarantee. This is not a guarantee. Okay, because guarantee simply means that with two ordered pairs, you cannot guarantee. If you say you can guarantee, then I will give you these two ordered pairs. Understand this. If you say that with two ordered pairs you can guarantee, then I will give you these two ordered pairs. I hope this point is clear. So remember, if you are taking these two ordered pairs, then that is just a possibility. That is not a guarantee. Okay. Now, with three ordered pairs, can you guarantee? With three ordered pairs, can you guarantee? With three ordered pairs, can I guarantee? Again, you cannot guarantee. See what I will do. I will give you, if you say that you can guarantee, then what I will do, I will give you this type of ordered pairs where this number will give you remainder 0. See, this will give you remainder 0. Okay, this will give you remainder 0 when you divide by 3. This will give you remainder 1 when you divide by 3. This will give you remainder 2 when you divide by 3. Is this point clear? See what I'm going to do. I'm going to do this type of situation. Okay, the second number does not matter. The second number does not matter. I hope you are getting this point. So if you say that with three ordered pairs you can guarantee, then what I will do, I will give you this type of number. For example, I will give you 3,5, 4,7 and 5,7. This type of things I will give you. Now here you can notice neither these are congruent to each other. These are also not congruent to each other. These are also not congruent to each other. Okay, so we don't have this type of pair. We don't have this type of pair. So I hope this point is clear, that with three ordered pairs also we cannot guarantee. Okay, there is no guarantee. We cannot guarantee. One important thing you understand, that we are not interested in these numbers. See, in these numbers, we are not interested. We are actually interested in these remainders, right? Agree? That this is your remainder 0 when you divide by 3. This is your remainder 1 when you divide by 3. And this is your remainder 2 when you divide by 3. Now, we are not interested in these numbers. These numbers you can change. Instead of 3, I can take 9. Instead of 4, what I can take? I can take 13, I can take. Okay, instead of 5, what I can do? Instead of 5, I can take, for example, maybe I can take 23, I can take. Okay, so this is what I'm saying. I am saying that we are not interested in these numbers. We are only interested in what remainder they are giving. This 9 is giving you remainder 0. This 13 is giving you remainder 1. And this 23 is giving you remainder 2. Okay, so I hope this point is clear. Now tell me. Now see something interesting. So ultimately, remember this simple point. This type of pair we want. We want AB, comma, CD. This type of ordered pair we want. Okay, where A mod 3, that is same as C mod 3. That is same as C mod 3. This is what we want. Now I'm telling you that if I give you 4 ordered pairs, then definitely 2 of them will satisfy this. See, if I give you 4 ordered pairs, now there is a guarantee. Now there is a guarantee that this type of couple you will find. This type of couple you will find. This is a couple. This is a couple. This type of couple of ordered pairs. This ordered pair, this ordered pair. I am calling it couple. Couple of ordered pairs. So this type of couple of ordered pairs you can find if I give you 4 ordered pairs. How I am saying this with guarantee? Tell me. How can I say this with guarantee? How can I say this with guarantee? The reason is simple. See, if I give you this ordered pair, okay, let me assume that this number give you remainder 0 when you divide by 3. Okay, let's try to make sure. Let's try to make sure that you don't get that this condition is not satisfied. Okay, what I will do, I will try to make sure that this condition is not satisfied. I will put my best efforts so that this condition is not satisfied. So tell me, if I give you the first ordered pair in which this number is remainder 0 when you divide by 3, can I give you remainder 0 when you divide by 3? Can I give you that? Can I give you that? No, because I want to dissatisfied. I don't want this to satisfy. I don't want this to satisfy. So I will give you remainder 1. Okay. Now, can I give you remainder 0? Can I give you remainder 0? No. Can I give you remainder 1? No. What I can do, I can give you remainder 2. Now you tell me, if I give you one more number, what automatically will happen? If I give you one more ordered pair, now automatically what will happen? Automatically. See, whether you take remainder 0, then they will be the couple. they will be the couple. If you take remainder 1, they will be the couple. If you take remainder 2, they will be the couple. So are you getting my point? Are you getting my point? See, whatever I do, because you know that if you divide by 3 remainders, only these are the possible remainders. Remainders when divided by 3. When divided by 3. What are the possible remainders? Remainders when divided by 3. Either this will be the remainder, or this will be the remainder, or this will be the remainder. So you can easily notice that in this ordered pair, this is remainder 0 when you divide by 3. This is remainder 1. This is remainder 2 when you divide by 3. Now, this ordered pair, whatever I give, whatever I give, either this will be the remainder 0. If this is remainder 0, then these two will be the couple. If this is remainder 1, then these two will be the couple. And if this is remainder 2, then these two will be the couple. But can I say that guarantee with 4 ordered pairs, I can guarantee that this type of couple I will find? Okay, that's it. This is your answer. I hope this point is clear. I hope this point is clear. Whatever you take here, whatever you do, this will be, I can say, this type of couple you will get. Okay, this type of couple you will get. So I can say that with 4 ordered pairs, I can guarantee. I hope this point is clear. With 4 ordered pairs, I can guarantee. So your answer will be what? I can say with 4 or more ordered pairs. If I take, remember, I can say if I take 4 or more ordered pairs, 4 or more, I can say greater than equal to 4 ordered pairs. If I take these many ordered pairs, then there is a guarantee. Okay, remember this point. Then there is a guarantee. No one can stop, basically. Then there is a guarantee that this type of couple you will get. We will get this type of couple, AB, CD, where A is congruent to C mod 3. This type of couple you will get. We can guarantee that this exists. Okay, I hope this point is clear. So in this question, the answer will be what? Tell me. If the condition is only this, if this is the condition, the answer will be 4. Okay, so for this variation, I can say the answer will be 4. Okay, so you can just, I can say the answer. The answer is going to be 4. Because the question is asking for minimum. Then that is the reason I can say with 4, I can guarantee. With 3, I cannot guarantee. With 2, I cannot guarantee. But with 4, I can guarantee. Okay, with 4, I can guarantee. Okay, now let's see this question. Now let me give you one more variation. Let's remove this and only see this. Now tell me the answer. See what I'm saying. Now I'm asking, what is the minimum number of ordered pairs of non-negative integers? Okay, ordered pairs of non-negative integers should be chosen to guarantee that there are this type of couples. This type of couples are there. There are this type of couples such that B is congruent to D mod 5. Okay, now what is the answer? Is this point clear? Okay, question is clear. See, the question is very simple. Again, the similar question, very similar. Basically, this type of couple we want. Okay, this type of couple, A, B, C, D. C, D. So this type of couple we want. Let's call it couple. This type of couple we want this condition that B mod 5 is equal to D mod 5. Okay, means they give you same remainder when you divide by 5. This type of couple we want. We want this type of couple such that they give you same remainder, B, D, they give you same remainder when you divide by 5. This type of couple we want. Okay, now again you can easily notice that if I take, let's assume 4 ordered pairs. With 4 ordered pairs, can you guarantee? With 4 ordered pairs, can you guarantee? With 4 ordered pairs, can you guarantee? No, we cannot guarantee, because what we will do? If you say that with 4 ordered pairs you can guarantee, then what I will do? Tell me. You are saying that with 4 ordered pairs, I can guarantee this type of couple. This type of couple will definitely exist. Okay, this is what you are saying. Then what I will do? I will create this type of situation. I will give you this where remainder will be 0 when you divide by 5. Okay, I will give you this in this ordered pair. In this ordered pair, this will have remainder 0 when you divide by 5. In this ordered pair, this will have remainder 1 when you divide by 5. In this, I will give you remainder 2 when you divide by 5. And in this, I will give you remainder 3 when you divide by 5. For example, what I can do this type of, for example, 2,5 I can give you, 2,6 I can give you, 3,7 I can give you, and for example, 8,8 I can give you. Is this point clear? You can notice in these 4 ordered pairs, we don't have a couple. There is no couple. Yes or no? Agree with me? Agree with me? In these 4 ordered pairs, there is no couple. There is no couple. So with 4 ordered pairs, you cannot guarantee. You can easily notice that this is giving you remainder 0, this is giving you remainder 1, this is giving you remainder 2, and this is giving you remainder 3. Okay, so if you say that with 4 ordered pairs you can guarantee, then I will give you this type of counter example. I will give you. You can notice that in these 4 ordered pairs, we don't have this type of couple. This type of couple we don't have. There is no this type of couple. Okay, now you tell me. Let's do one thing. Let's try to prevent this from happening. Let's do that. Okay, as much as possible. What I will do, I will make sure that this does not happen. I will make sure that this type of couple does not occur. So if I want to make sure that this type of couple does not occur, then what I can do? For example, I can give you this ordered pair where this is remainder 0 when you divide by 5. Okay, now you tell me, in this, will I give you remainder 0 when you divide by 5? Will I give you remainder 0? No, I will give you remainder 1 because I want to make sure that this couple does not occur. Okay, I don't want this couple. Okay, now you tell me, can I give you remainder 0? No. Can I give you remainder 1? No, because I don't want this couple. So what I will give you remainder 2. Okay, in the next, what I will do, I will not give you remainder 1, remainder 0, remainder 2 because I don't want this couple. So what I will do, I will give you remainder 3. In the next ordered pair, what I will do, I will give you remainder 4. But now something interesting will happen. So far there is no couple. Remember, so far there is no couple. Here you can notice there is no couple. We don't have any couple. There is no couple. This type of couple we don't have. You can notice. Okay, you can notice we don't have this type of couple. But if I give you one more ordered pair, then definitely a couple will come. Agree with me? If I give you one more ordered pair, now definitely a couple will come. Definitely there is a couple. Definitely there is a couple. Some couple will come. Definitely some couple will come. Because what will happen? See, whatever number I give you here, whatever number I give you here, if that is remainder 0, then these will create a couple. If that is remainder 1, then these will create a couple. If that is remainder 2, these will create a couple. If this is remainder 3, when you divide by 5, then these will create a couple. And if this is remainder 4, when you divide by 5, then these will create a couple. And only these are the possible remainders. This. 0 to 4. These are the possible remainders when you divide by 5. So definitely some couple will come. Agree with me? So here in this question, what I can say that with the 6 ordered pairs, or I can say greater than equal to 6 ordered pairs will guarantee. Greater than equal to 6 ordered pairs will ensure. Agree with me? Okay. Greater than equal to 6 ordered pairs. Greater than equal to 6 ordered pairs will ensure. The question is asking for minimum. The question is asking for minimum. So what will be the answer? So what is going to be the answer? So for this variation, the answer will be 6. Remember, we are only solving the variations right now. Right now, we are only solving the variations. Did you understand these 2 variations? Please tell me. Now let me ask you one more variation. Let me ask you this one more variation. Some interesting variation I am asking. You tell me the answer. What I tell you that such that this type of ordered pairs we want, this type of couple we want, remember this type of couple we want this type of couple. And I'm saying that A also should be even and C also should be even. A also should be even and C also should be even. Let's assume this option is none. Okay, and some other options are there. Some options I am giving you. For example, I can give you some options. Let me give you some options. You think about it. I'm giving you some options. I'm giving you option 1, that is 1, option B, that is 2, option C, that is 3, option D, that is 4, option E, that is 5, option F, that is 6. And this is your another option, that is none. Now tell me the answer for this question. Please understand what I want. First of all, what I am choosing? Tell me. Just tell me what I am choosing. I am choosing ordered pairs. Okay, right? Yes or no? I am choosing what I am choosing. I am choosing ordered pairs. Ordered pairs I am choosing. I am collecting ordered pairs. Okay, you already know. I am collecting ordered pairs. And what I want this type of couple. AB, CD, this type of beautiful couple I want. This type of beautiful couple I want where A is also even and C is also even. This type of beautiful couple I want where, so this type of couple I want. Okay, let me call it a couple. Let me call it a couple. So I want a couple. Okay, I am choosing ordered pairs. I'm choosing back to back. I am choosing ordered pair. I am collecting ordered pairs. And this type of couple I want. So you tell me, minimum how many ordered pairs I need to choose so that I can get this type of couple. This type of couple I want. To get this type of couple, to ensure this type of couple, to definitely get this type of couple, remember, to definitely get this type of couple, minimum how many ordered pairs should I choose? Minimum how many ordered pairs should I choose? Tell me. Tell me. To definitely get this type of couple, minimum how many ordered pairs should I choose? Okay, I want this type of couple where A is also even, C is also even. So what is the best strategy? What is the best strategy to prevent it? Make sure that this type of couple is not there. Okay, so the best way, what is the best way? Best way to solve, what is that? Tell me what is the best way to solve this type of question? The best way to solve this type of question is make sure this type of couple does not create, you don't create. Okay, just make sure that you don't create this type of couple. Make sure that you don't create this type of couple. You don't create this type of couple. This type of couple. Basically prevent this type of couple from happening. Make sure that you don't create this type of couple. Okay, you tell me. If I want to make sure that this type of couple I don't create, then what I can keep doing? Please tell me what I can keep doing. What I can do? I can just take 3,5, then I can take 5,7, then I can take 9,10, then I can take 11,10, then I can take 13,10, then I can take 15, anything 23. Are you getting my point? Are you getting my point? So basically nothing can guarantee this type of couple. See, A must be even, C must be even. I can keep choosing ordered pair. First I can choose this ordered pair, then I can choose this ordered pair, then I can choose this ordered pair, then I can choose this, then I can choose this, then I can choose this ordered pair, and so on. Nothing can guarantee this type of ordered pair. Yes or no? This type of couple. Nothing can guarantee this type of couple. Do you agree with me? Please tell me, did you understand? See, some students are saying that 4 ordered pair will guarantee. Let's assume your answer is 4. Let's assume your answer is 4. Assume your answer is 4. Assume you are saying that with 4 ordered pairs, this type of couple will definitely create. Okay. See, if you are saying your answer is 4, that means what? Please tell me, that means what? That means you are saying what? You are saying that with 4 ordered pairs, definitely this couple will create. Yes or no? Agree? This is what you are saying. Agree with me? If you are saying answer is 4, then it means you are saying that with 4 ordered pairs, definitely this type of couple will exist. This type of couple will be created, will occur. But what I can do? But what I can do, I can give you 4 ordered pairs, no problem. I can give you 4 ordered pairs. For example, I can give you this ordered pair 5,7. I can give you this ordered pair 5,10. I can give you this ordered pair 7,11. I can give you this ordered pair, for example, 19,100. See, did you get a couple? Please tell me. Please tell me, did you get a couple? Did you get a couple? No, there is no couple. There is no couple here. You can see, and can you notice, like this, I can keep giving you. Like this, I can keep giving, for example, 29,10. Like this, I can keep giving you, and you will never get this type of couple. So can you guarantee this type of couple? Can you guarantee this type of couple? So you can see there is no couple. Did you understand pigeonhole principle with this example? With this example, did you understand that this type of couple we can never create? Sorry, we can never guarantee. This type of couple we can never guarantee. Is this point clear? This type of couple we can never guarantee. So the answer will be none. Okay, you can collect, for example, you can select 100 ordered pairs. Will that guarantee that this type of couple will be there? If I give you 100 ordered pairs, is there any guarantee this type of couple will be there? Is there any guarantee? No, there is no guarantee. If I give you 1 crore, we have 1 crore, let's assume I give you 1 crore ordered pairs. Is there any guarantee that this type of couple will be there? Is there any guarantee? Again, there is no guarantee. So the simple point, we can never guarantee this type of couple. I hope this point is clear. So this is a good question for your thinking, because see, some students will answer for some will give this answer, some will give this answer. Are you getting my point? Some students will give this answer, some will give this answer, someone will give this answer. Okay, so but understand that we can never guarantee this type of couple. Now let me ask you another question, another variation. Let me ask you. So in this question, consider this variation. I'm asking you many variations so that you can completely understand this question. Whatever in the GATE exam, whatever they ask you in future, you can answer that question with very confident, I can say, very confidently you can answer that question. So that is the reason these variations I'm asking. Okay, now you tell me the answer for this question. You want this type of couple. You want this type of couple you want, which satisfy this condition that A, C have same parity, A, C have same parity, and B, D have same parity. Okay, A, C have same parity, and B, D have same parity. Did you understand this question? What parity means? Do you remember? What parity means? Same parity means? Same parity, what that means? Same parity means either both even or both odd. Yes or no? Either both even or both odd. Same parity means either both even or both odd. For example, I can say 4, 10 have same parity. They have same parity, right? Because they are both even, so they have same parity. You can notice that. You can notice 5, 7 have same parity because they are both odd. You can notice 4, 5 have different parity. They have different parity because this is even, this is odd. And similarly, you can notice 19, 10 have different parity because this is odd, this is even. So you know what is parity. Now you tell me the answer for this question. A, C have same parity and B, D have same parity. A, C, they have same parity, and B, D, they have same parity. Now you tell me the best way to solve this question. What is that? Tell me what is the best way to solve this question. That is, don't create this type of couple. Make sure you don't create this type of couple. See, I want this type of couple. This type of couple I want. I want this type of couple. So the best way to solve, what is that? The best way to solve, that is, prevent this type of couple. Prevent such couple. Prevent such couple. Okay, very simple. Just prevent such couple. Prevent it. Prevent such couple. So, okay, To prevent such couple, the first number that I will give you, I can give you, for example, maybe I can give you maybe odd comma odd, odd comma odd, right? Odd, odd. See, this is not zero, this is odd. See, this is not zero, this is odd, this is not zero. This is not zero, this is O. This is not zero, okay? So I can give you this number, I can give you odd odd. What second number I can give you? They have same parity and they have same parity. So here also you can notice one thing, that I can keep giving you and you can never guarantee. What I can do, see what I'm saying, I can keep giving you, but you cannot guarantee. Because remember, A comma C should have same parity and B comma D should have same parity. Okay, so what I can do, I can give you this type of number. For example, here you can notice that here I will give you 5 and here I will give you 10. Here I will give you 5, here I will give you 8. So they have same parity. Okay, I will give you, okay, no. If I give you this type of number, so I want to prevent. Okay, so let's make sure. Okay, let's make sure that we prevent. Okay, so let's try to prevent such couple. So if I start with, for example, let's assume I start with 5,7. Okay, I want to prevent this type of couple. They should not have same parity. Okay, and so for example, I can give you 6,8. So far it is correct, right? Yes or no? We don't have couple. What I can do in the next, I can do what? I can give you what? Tell me. I can give you, for example, I can give you 10, if I give you 10, 12, what will happen? If I give you 10, 12, what will happen? See, here you have odd, odd. Here you have even, even. Okay. If I give you this type of ordered pair, then you got a couple. Right? Then you got a couple. So I cannot give you even, even. I cannot give you even, even. I cannot give you odd, odd. So what should I do? I cannot give you even, even. Here, I cannot give you even, even. I cannot give you odd, odd. So what I can do? I can give you, for example, even, okay, for example, I can give you even, odd. Okay, even, odd I can give you. Now I cannot give you even, odd. Now what I will have to give you? See, I cannot give you odd, odd. If I give you odd, odd, then what will happen? If I give you odd, odd, then what will happen? They will create a couple. Agree? They will create a couple. If I give you even, even, they will create a couple. If I give you even, odd, they will create a couple. So the last choice is I can give you odd, even. I can give you odd, even. Okay, I can give you, for example, odd, even. Now, something interesting. So far, no couple. Agree? So far, there is no couple. So far, there is no couple. We don't have any couple so far. So far, there is no couple. So far. But if I give you one more, now what will happen? Definitely a couple will come. Yes or no? Now, if I give you one more, now definitely couple will occur. Now, definitely couple occurs. Agree? Did you understand this question? Please tell me. Did you understand this question? If I give you one more, now what should I give you? Should I give you odd, odd? If I give you odd, odd, they will create a couple. If I give you even, even, they will create a couple. If I give you even, odd, they will create a couple. If I give you odd, even, they will create a couple. So whatever I do, one couple will create. Agree with me? Whatever I do, you will definitely get a couple. Please tell me, is this point clear? So for this question, the answer will be what? If you want this type of couple, then the answer will be what? If you want this type of couple, then the answer will be 5. Okay. So this variation, did you understand? Please tell me. We have taken some variations we have taken. Did you understand these variations? So far, all the variations that we have taken, did you understand? Please tell me. Are you understanding what is happening here? Okay. So far, all the variations. In this previous question, can you notice? See, Anurag is asking, but the question was that both should have same parity, not only one couple. No. See, the question was this. Read the question. A comma C have same parity and B comma D have same parity. Anurag, we want this type of pair. Okay, we want this type of pair where in a couple what happens? In a couple this happens that this type of couple means A comma B, C comma D. The question is saying that they must have same parity. They must have same parity and they must have same parity. And they must have same parity. Is this clear? And there is and between them. There is and between them. Okay, there is and. Please tell me, is this clear? Both conditions must satisfy. Yes, of course. You can notice both conditions will satisfy if you add one more. If you add one more, then both conditions. So far, these conditions are not satisfied. You can notice so far, these conditions are not satisfied. So far. Is this clear? Tell me. Anurag, did you understand this? See, if I give you this question in the previous, if I give you this variation that, let me give you this variation. For this, I give you this variation that A comma C have same parity or A comma C have same parity or B comma D have same parity. Now what will be the answer? Now what will be the answer? Think about it. Now what will be the answer? I am saying A comma C have same parity or B comma D have same parity. Now the answer will be what? Now what is going to be the answer? Either A comma C should have same parity or B comma D should have same parity. So remember now my couple definition. What is the couple definition now? Couple means either they have same parity, either this happens, either they have same parity or they have same parity or B comma D have same parity. So now this is the couple definition. Either this happens or this happens. Now the answer will be what? See, very simple. Let me give you the first number, which is even comma even. What is the second number which I can give you such that condition is not satisfied? Make sure this condition is not satisfied. So tell me, what is the second number I can give you? Can I give you even comma odd? If I give you even comma odd, I got this, and that is enough. See, because there is or between them. Because there is or between them. So can I give you even comma odd, or can I give you odd comma even? If I give you this, then the condition is satisfied. So I have to give you odd comma odd. Now what is the third thing I will give you? So far condition is not satisfied. So far there is no couple. So far there is no couple. Now you tell me, if I give you one more, now what will happen? If I give you one more, either they will create a couple or they will create a couple. So for this question, the answer will be what? If I give you one more, now definitely you will get a couple. Definitely a couple you will get. There is a guarantee you will get a couple. So for this question, the answer will be what? Answer will be 3. Anurag, is your doubt clear? Now is your doubt clear? We have done the variation and here we have done the variation or. The variation of and, the variation of or, both of them we have seen. Okay, now let's move on to this GATE question. Let's solve this GATE Computer Science 2005 question. Let's solve it. So the question, what this question is saying? This is saying that minimum number of ordered pairs of non-negative numbers, non-negative integers basically, okay, that should be chosen to ensure. We want to ensure, remember. What we want? We want a guarantee. This type of guarantee we want. We want to ensure that we get this type of couple where this happens. Okay, so see what the question is saying. Question is saying that you keep, the question is saying you are choosing ordered pairs. Okay, this is what the question is saying. Question is saying that what you are doing, we are choosing ordered pairs. We are selecting ordered pairs. It's like this. We are selecting ordered pairs. Okay, and the question is saying that We want this type of ordered pair. We want this type of ordered pair, means A comma B, C comma D. This type of ordered pair we want. Let's call it a couple. Okay, this type of ordered pair we want where A is congruent to C mod 3 and B is congruent to D mod 5. This is the question. Okay, let's call it a couple. For this type of ordered pair, let's call it a couple. Is this point clear? We are calling it a couple. Means I'm saying that, see, we are choosing ordered pairs. We are choosing ordered pairs of non-negative integers. This is what we are doing. We are selecting ordered pairs. And this type of ordered pairs we want. We are calling it a couple. This we are calling it couple. This type of ordered pair we want. This A, B, C, D, two ordered pairs we want where A comma C, they give you same remainder when you divide by 3. They will give you same remainder when you divide by 3. And they will give you same remainder when you divide by 5. Okay, so this is AND. Both of them should happen. This also should happen and this also should happen. Okay, this A comma C should give you remainder, same remainder when you divide by 3. This B comma D should give you same remainder when you divide by 5. This type of I can say pair. This type of pair we are calling it a couple. We want a couple. The question is saying minimum how many ordered pairs should I choose such that there is a guarantee. Such that there is a guarantee that we will get a couple. That we will get a couple. Okay, so this is the question. Now tell me what you will do. You will try to prevent it. So just make sure that you don't get this type of couple. The best way to solve this question is prevent this type of couple. Okay, we are calling it a couple. We are calling it a couple, and the best way is prevent it. Prevent it. Okay, so this is the best way to solve. Best way to solve. What is that? That is prevent couple. You don't want couple. Make sure that you don't get couple. Okay, prevent couple. Now you tell me one thing. I want to prevent a couple. So what I can do? See, the first number that I can take, only the remainder matters, right? Do you agree with me? We only care about the remainder. Couple means A comma B, C comma D. Okay, this type of pair where they have the same remainder when you divide by 3. Same remainder. They should have same remainder when you divide by 3, and they should have same remainder when you divide by 5. Same remainder when divided by 5. And similarly here, same remainder when you divided by 3. This also should have same remainder when divided by 3. Okay, we only care about the remainder. We don't care about these numbers. We only care about the remainder. What I can say, the first number I give you, let's assume this type of number I give you where, remember, this is remainder by 3. Okay, what I'm going to do, please understand. In every ordered pair that we take, I will write remainder here. I will write remainder here. This here, I will write remainder by 3. And here I will write remainder by 5. Okay, here I will write remainder by 5. This is what I'm going to do. So now you tell me. The first number, the first ordered pair that I take, let me take this 0, 0. Means when you divide by 3, this number, the remainder is 0. And when you divide by 5, this number, the remainder is 0. Let's assume this is the first ordered pair I'm taking. So if I'm taking this ordered pair, can the second ordered pair I can take 0, 0? Can I take that? Are you getting my point? See, these are not actual numbers. Please understand, these are not actual numbers. For example, I can take 3 here, I can take 5 here. Because if you notice, this is nothing but remainder 0. This is nothing but remainder 0. And this is nothing but remainder 0. When you divide by 3, remainder 0. When you divide by 5, remainder 0. Can I take 6, 10? Can I take 6, 10? Here also you can notice, when you divide by 3, remainder 0. When you divide by 3, remainder 0. Sorry. When you divide by 3, remainder 0. When you divide by 5, remainder 0. So can you notice they are making a couple? Can you notice they are making a couple? Yes or no? They are making a couple. But we don't want a couple. They are making a couple, but we don't want a couple. So what I am saying that first number you are taking, take like this. Here remainder 0. Here remainder 0. What is the second number you can take? What is the second number you can take? In the second number, what I can do, I can simply keep this same, but I can keep changing this. I can make remainder 1. I can make remainder 0. In the third number, what I can do, I can keep this remainder 0, I will keep same. But here I will take remainder 2. Here I will make remainder 2. So far, did we get a couple? Please tell me. So far, did we get a couple? Remainder 0 when you divide by 3. Remainder 0 when you divide by 5. Remainder 1 when you divide by 3. Remainder 0 when you divide by 5. Remainder 2 when you divide by 3. Remainder 0 when you divide by 5. So far, there is no couple. So far, you can notice, so far, there is no couple. So far, there is no couple. Now you tell me what is the next. Can I prevent the couple in the fourth ordered pair? In the next ordered pair, can I prevent the couple? Can I prevent the couple in the next ordered pair? In this next ordered pair, can I prevent the couple? Yes, I can prevent the couple. See, here whatever I do, either that will match with this or with this or with this. But I can change this. Okay, I can change this. What I can do, see, I can make this remainder 1 and I can keep this remainder 0. Like this. Here, in the next, what I can do, I can keep this remainder 0. Here I can make remainder 2. Then in the next, I can do like this. In the next, what I can do, I can take 0, 3. In the next, I can make 0, 4. So far, did we get a couple? So far, in this, so far, did we get a couple? Please tell me. So far, in this, did we get a couple? So far, there is no couple. Now you tell me what I can do. The same thing. Here I can take remainder 1. Here remainder 1. Okay, here remainder 2, 1. Here, what I will do? Tell me. I will keep it same, but 1, 2. Okay, I will make it 1, 3. I will make it 1, 4. Then I will make it 2, 2. Then I will make it 2, 3. Then I will make it 2, 4. So far, did you get a couple? Please tell me. Did you get a couple so far? In this question, did you get a couple so far? So far, there is no couple. You can check it out. So far, there is no couple. But if I add one more, then what will happen? If I add one more ordered pair, you can guarantee that that ordered pair will make a couple with one of them. With one of them, that will make a couple. Is this point clear? See, here I can say so far there is no couple. Here I can say so far in this I can say there is no couple. There is no couple. But if I add one more in this complete, there is no couple. There is no couple. But if I add one more, now definitely there will be a couple. So the answer will be what? The answer will be total 16. If you have 16 ordered pairs, then definitely you will get a couple. Did you understand this? Please tell me, did you understand this question? See, the question is very simple question. In this question, you can notice this is what we want. Please understand what we want in this question. Let me tell you. We want a couple. We want a couple. Okay, first of all, what is a couple? Let me tell you. First of all, what is a couple? Couple is AB, CD. This type of two ordered pairs, that is a couple. This type of two ordered pairs is a couple. And the condition is this, that A, C have same remainder when you divide by 3. Have same remainder. Or I can say that A mod 3 is the same as C mod 3. A mod 3 is same as C mod 3, and there is and B mod 5 is the same as D mod 5. This is the question. Okay, very simple. This is the we are saying that this is the couple. Remember, this is the definition of couple. We are saying this complete thing is a couple. The complete thing. This is called a couple. Now, we want this type of couple. This also should happen. This also should happen. So maximum how much you can prevent? See, maximum how much you can prevent? You can prevent this. If you want to prevent this, then maximum what you can do? You can create 3 categories. See, if you want to prevent this, if you want to prevent this A mod 3 equal to B mod 3, If you want to prevent this, then how many categories you will get? If you want to prevent A mod 3 equal to B mod 3, then 3 categories will be there. Then there will be 3 categories. What will be the 3 categories? What will be the 3 categories? One will be remainder 1, one will be remainder 0, another will be remainder 1, another will be remainder 2. 3 categories will be there. Okay, yes or no? If you want to prevent A mod 3 equal to B mod 3, if you want to prevent this, 3 categories you can create. Now you can notice within each category, in this category, if I take 2 ordered pairs, then can I prevent this condition? Please tell me. In this category, if I take 2 ordered pairs, then can I prevent this condition? Can I prevent this condition? No. But what I can do? But I can prevent this condition. Because remember, the question is saying that this also should happen and this also should happen. This is important and this is important. The question is saying that this first also should happen and this also should happen. So in this category, if I take 2 ordered pairs, then I cannot stop this. I cannot prevent this, but I can still prevent this. I can still prevent the second condition. So in this first category, tell me how many ordered pairs I can take to prevent this second condition. Is if you want to prevent the second condition, if you want to prevent the second condition in this category, if you want to prevent the second condition, how many ordered pairs I can take to prevent second category? How many ordered pairs I can take? Please tell me. To prevent second category, I can take 5 ordered pairs. I can take 5 ordered pairs. What will be these 5 ordered pairs? These 5 ordered pairs will be something like this, like 0, 0, remainder 0, 0, remainder 0, 1, remainder 0, 2, remainder 0, 3, remainder 0, 4. Understood? Understood this? Remainder 0, 0, remainder 0, 1, remainder 0, 2, remainder 0, 3, remainder 0, 4. Similarly, in this category, if you want to prevent second condition, similarly, in this category, if you want to prevent second condition, then how many ordered pairs you can create? Again, you can create 5 ordered pairs. Again, you can create 5 ordered pairs. And the same thing will happen in the third one. Okay, again, you can create 5 ordered pairs. These 5 ordered pairs will be something like this. For example, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. And in this third category, if I want to prevent second condition, again, I can create 5 ordered pairs. Again, 5 ordered pairs I can create. Okay, these 5 ordered pairs will be like this: 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. Okay, so this is the final point, that total 5 ordered pairs here, 5 here, 5 here. Total 15 ordered pairs I can create to prevent this couple from happening. So this is what I can do to prevent couple. I can say that to prevent couple, maximum 15 ordered pairs I can create. Maximum 15 ordered pairs I can create. Maximum 15 ordered pairs I can create. So it simply means that if you have 16 or more ordered pairs, definitely couple will come. If you have 16 or more ordered pairs with greater than equal to 16 ordered pairs, definitely a couple will come. Definitely couple occurs. So this is your question, and for this question, the answer will be 16. This was your GATE exam question, and for this, the answer is going to be 16. Can you generalize it? We will generalize it, but before that, we will take one variation. In the same question, we will generalize this, but before that, you tell me if there is OR here. Now what will be the answer? If there is OR, now what is the answer? If I put OR here, now the answer will be what? Either this happens or this happens. Now the answer will be 4. Now the answer will be 4 because with 4 ordered pairs, this will happen, right? Yes or no? If you take 4 ordered pairs, then definitely this will happen. Understand? Is this point clear? With 4 ordered pairs, definitely this will happen. Definitely this will happen. So the answer will be 4. Did you understand this? Please tell me. Is this point clear? See, I have this condition: A, B, C, D, and I am saying that either A congruent to C mod 3, or there is or here. There is or. B is congruent to D mod 3, D mod 5. Now in this question, you can notice if you take 4 ordered pairs, then see either this should happen. Let me call it P, or this should happen. Let me call it Q. Now you can notice with 4 ordered pairs, what you can guarantee? With more than equal to 4 ordered pairs, what you can guarantee? If you take more than equal to 4 ordered pairs, P will definitely happen. This P will definitely satisfy. Yes or no? P will definitely satisfy. P will definitely satisfy. So if P is satisfied, then that's it. One condition we want, because there is or. So for this question, the answer will be 4. Did you understand this variation? Did you understand? Okay. Now let me ask you, can you generalize this? This question, can you generalize? If you have here mod M, here mod N. Here if you have mod M, here you have mod N. Can you generalize this? The answer will be what? In this situation, what will be the answer? In this situation, the answer will be Mn plus 1. Mn plus 1. This will be the answer, right? Yes or no? Because remember again the same thing. See, this is a beautiful question, let me tell you. This type of pair, we want this type of couple. We want this type of couple where A is congruent to C mod M. Okay, mod M. And B is congruent to D mod N. And there is AND here. So you tell me, what is the best solution? See, we are only interested in the remainders. We want this also, right? And you know that we are only interested in the remainders. Very simple question, that we are only interested in the remainders. Means this ordered pair. Tell me what you will check. When I give you 2 ordered pairs, what will you check? You will check what remainder they are giving you when you divide by 3, and what remainder they are giving you when you divide by n. Yes or no? If I give you 2 ordered pairs, what you will check? You will check remainder when divided by m. Remainder when divided by m. This is what you will check. And remainder when divided by n. This is what you will check. Right? Agree with me? Remainder when divided by n. This is what you are going to do. You are only interested in the remainders. Our only interest is the remainders. Only interested is the remainders. This is our only interest. So tell me how many remainders you can create. How many? Means such that this condition does not satisfy. How many such pairs you can create? Very simple. If you prevent this condition, then total m categories will be there, right? Okay, yes or no? If you prevent, let me call it for a moment what I'm doing. Let me call it P, and let me call it Q. So if you prevent P, then how many categories will be there? To prevent P, how many categories will be there? To prevent P, m categories will be there. M categories. Okay. To prevent P, m categories will be there. Within each category, you can create n categories to prevent Q. Okay. Within each category, to prevent Q, we can create how many? within each, to prevent Q, we can create n ordered pairs. N ordered pairs we can create. Simple. Okay. So finally, I can say that if you want to prevent this couple, if you want to prevent couple, if you want to prevent this couple, then mn ordered pairs can be created. Maximum mn ordered pairs can be created. Maximum mn ordered pairs can be created. Maximum these many ordered pairs we can create. We can create. Okay. But it simply means that if you have one more with mn plus 1 with these many ordered pairs, what will happen? With these many ordered pairs, what will happen? With these many ordered pairs, definitely a couple you will get. Definitely couple. Okay, very simple. Definitely couple occurs. So this is your answer. Okay, simple. Okay, right? So the answer will be mn plus 1. This is the generalization. In the same question, if I ask you the generalization when you have OR, then answer will be what? In the same question, for example, let's assume I give you this type of question. Like, for example, here I give you m, here I give you n, and here I give you OR. Okay, here I give you OR. Understand my question. First, you understand my question that I am saying that I give you OR here. Now the answer will be what? Answer will be whatever is minimum of m comma n plus 1. This will be the answer. Okay. So these are some generalizations. Now can you answer this question? This is your Kenneth Rosen 6.2 exercise 6.2 question. What the answer? You want and here. So the answer will be what? There is and here. Means mod 5 mod. So here the answer will be 5 into 5 plus 1. The answer will be 5 into 5 plus 1. This will be the answer. So the answer will be 26. In the same question, if I put over here, then answer will be what? If I put over here, then the answer will be 6. Clear? Crystal clear? Shall we move on to the to some more questions? Is this crystal clear? Let me tell you. Let me tell you why we have done so much analysis. Some of you might be thinking, sir, I got the answer. Before this session, I already got the answer. Let me tell you, for this particular question, a lot of students, they don't even understand what is happening. That is the reason I've given you some small variations, and then we have come to the question. And in the question also, I've given you the generalization, the variations. Okay, this complete analysis that we have seen, including the variations, including the small questions. Okay, basically everything that we have seen so far. This I have told you because there are a lot of students who don't understand this question, who don't understand what is happening in this question. Okay, so that is the reason this complete analysis I have given to you. Please tell me all the small points, did you understand? The question was easy, but did you understand all the small points? Okay, so let's move on. Let's solve this question. This is Kenneth Rosen, exercise 6.2, question number 5. What is the answer? Show that among any group of 5, not necessarily consecutive integers, means any 5 integers you take, there are 2 with the same remainder when you divide by 4. Can you prove it? Can you prove it? Yes, of course you can prove it. See, the simple question. The question is saying that if you take 5 integers, means you take, for example, A, B, C, D, E. If you take 5 integers, then there is a guarantee that 2 of them will have same remainder when you divide by 2. Okay, there is a guarantee that 2 of them have same remainder. 2 of them have same remainder when divided by 4. When divided by 4. And this is obvious. Why? With pigeonhole principle, you can say, tell me what are the possible remainders when you divide by 5? 4. Possible remainders when divided by 4. When divided by 4. The possible remainders. What are the possible remainders? The possible remainders are 0, 1, 2, 3. Okay. So now the question is saying that two of them definitely have same remainder when you divide by 4. And this is very simple. See, let's prevent same remainder when divided by 4. Prevent same remainder when divided by 4. Then how many numbers you can take maximum? Prevent same remainder when you divide by 4. Then what you can do? You can take a number which gives you remainder. You can take this number which gives you remainder 0. You can take this number which gives you remainder 1. You can take this number which gives you remainder 2. Because you want to prevent same remainder. Prevent same remainder. So you can take this number which gives you remainder 3. You can take this number which gives you remainder 3. Now tell me, if I take fourth number, what will happen? See, if I take the fourth number and you divide by 4, either the remainder will be 0. If the remainder is 0, they have same remainder. If the remainder is 1, they have same remainder. If the remainder is 2, they have same remainder. If the remainder is 3, they have same remainder. So whatever you do, remainder will repeat. Yes or no? Remainder repeats. Some remainder repeats. Definitely, some remainder will repeat. Okay. Maybe this will give you remainder 2. If this gives you remainder 2, then they have the same remainder. These two have the same remainder. So very simple. The question is very simple. Now tell me the answer for this question. This is generalization, right? If d is a positive integer, then if you take d plus 1 integers, then definitely there are two numbers with the same remainder. Yes or no? This is just a general result. Because if you take, for example, if you take d, which is some positive integer, this d is some positive integer. Now, what are the possible remainders when you divide by d? What are the possible remainders when divided by d? What are those? See, these are the possible remainders, 0, 1, 2, and so on, d minus 1. These are the possible remainders. Now you can easily see that if I take d plus 1 numbers, if I give you d plus 1 numbers, see, I can give you this number which gives you remainder 0. I can give you this number which gives you remainder 1. Like this. I can give you this number which gives you remainder d minus 1. But if I give you one more number, see, if I give you one more number, if I give you, for example, this number b, then if you divide by d, this b, if you divide by d, then either the remainder will be 0. If the remainder is 0, they have the same remainder. If the remainder is 1, they have the same remainder. If the remainder is d minus 1, they have the same remainder. So whatever you do, definitely some remainder will repeat. Some remainder repeats. Definitely some remainder will repeat. So this is the general result. If d is a positive integer, then if you take any group of d plus 1 integers, any group of d plus 1 integers, if you take, then at least 2 have the same remainder. Okay. Now this is the last thing that we need to do in the pigeonhole principle. In the pigeonhole principle, we have seen everything we have seen, but this last result we need to see. Let me tell you why this result is important. Because this result you will find in every pigeonhole principle book. In any standard book, if you read the pigeonhole principle chapter, then definitely this question you will definitely find. Okay, so this question is actually interesting. Maybe someday they can ask you, and variations also can be created. We will see. But before we see this result, this cool result we are going to see, before that, you tell me one thing. Before we see this, you tell me a simple point. Let's assume you have some n is some positive integer. Let's assume n is some positive integer. Now you tell me, if I give you a comma b, this is giving you me remainder. Let's assume that a mod n, that is also means remainder. Let's assume the remainder is r, and this is also giving me remainder r. Okay, both of them are giving me remainder r. Then tell me what remainder a minus b will give me. Please tell me what will be a minus b mod n, what that will be. That will be 0, right? Very simple. Very simple. Okay, you can easily notice that if a comma b, they give me same remainder when you divide by n. A comma b, they are giving me same remainder when you divide by n. Then a minus b will give me remainder n. This is actually by the definition of congruence, if you remember. If you remember, this is the definition. A is congruent to b mod n if and only if n divides a minus b. Agree? Agree or not? Yes or no? A is congruent to b mod n if and only if a n divides a minus b. This is the definition of congruence. This we already know. Now let's see this question. Now consider this question. This question is saying that whatever natural number you take, there is some non-zero multiple of n which contains only 0, 1s. First, you understand this question, what the question is saying. The question is saying that whatever natural number you take, okay, for any n which is a positive integer, what will happen? This n divides some number which is only contains 0, 1s, and divides some number t such that t contains only 0, 1s. T contains only 0, 1s. Did you understand this theorem? Did you understand? Please tell me. See, whatever natural number you take, for any natural number, this n will divide some integer which contains only 0, 1s. For example, this 2 divides whom? For example, you can notice 2 divides whom? For example, 2 divides 1, 0. Okay, 2 divides 1, 0. 3 divides whom? Tell me. 3 divides whom? Tell me. 3 divides whom? Let me know. 3 divides 1, 1, 1. You can check it out. 3 divides 1, 1, 1. Similarly, 4 divides whom? 4 divides whom? Means basically every number, whatever number you take, that will divide someone which contains only 0, 1s. For example, 5 divides this. 4 divides whom? For example, 4 divides 1, 1, 0, 0, I think. Or maybe 1, 0, 0. 1, 1, 0, 0 will also work. Right? Okay. So I hope you understand this point. So the theorem is this. This is the theorem that for all n positive integer, okay, there exists some t such that t contains, there exists some t such that two things will happen. N divides t and t contains only 0, 1. T contains only 0, 1s. I hope this point is clear. Understood this? You can again read this. So there is a multiple of n. For any positive integer, there is a multiple which you can write only in terms of 1, 0. Okay, using only 1, 0. I hope this point is clear. Anyone has any trouble in understanding this point? Please tell me. Did you understand this point? Let me know. So very simple point, that whatever number you take, only 1, 0 should be there. It will divide some number which contains only 1, 0. Any number you take, every number. So whatever n you take, positive integer n, whatever positive integer n you take, it will divide some t where t contains only 0, 1. How to prove it? This cool result, how to prove it? The proof is also by Pigeonhole principle. Proof is by Pigeonhole principle. How to prove it? Let's prove it. See, you take, let's prove it for initially, let's prove it for some number. For example, for n equal to 9, how to prove it? For n equal to 9, how to prove it? Let's try to prove for n equal to 9. You don't have to give me a number. Okay, using Pigeonhole principle, we will prove that this 9 has some multiple which you can write only in terms of 1, 0. So for 9, how to prove it? See, very simple. Consider these numbers. I am giving you total One more thing I want to ask you, very simple thing I want to ask you. If I give you 10 integers, can I say two of them will have same remainder when I divide by 9? Tell me, if I give you 10 integers, then tell me, if I give you 10 integers, can you guarantee that two of them will have same remainder when you divide by n? Yes. Okay, very simple point. So if I give you 10 integers, these integers, consider these integers: 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 5, 6 ones, 7 ones, 8 ones, and 9 ones, and 10 ones. Okay, like this. And finally, 10 ones. Okay, now you consider how many numbers I gave you. Please tell me how many numbers I gave you. I gave you 10 integers. Total 10 integers I have given to you. 10 integers I have given to you. Okay. Tell me, what is this number? This is not binary. This is 111, 111, 111. This is 111. These are not binary. Okay. See, these are not binary. It's not like this is 3. This is not 3. This is 11. Please understand. This is 11. This is 11. What is this? This is 1111. Okay, yes or no? This is 11. Similarly, like this is your 111. Is this point clear? So total, how many integers I have given to you? Total 10 integers I have given to you. You tell me, can you guarantee two of them will give you same remainder when you divide by n? When I divide by n, can you guarantee two of them? I don't know which. But can you guarantee that two of them will give me same remainder when I divide by n? When I divide by 9? Yes, of course. Because you already know this result. You already know this result that we already know. This we already know that for all n belonging to positive integers, okay, if we have a set of n plus 1 numbers, then at least two of them will give you same remainder when you divide by n. At least two of them give same remainder when divided by n. This we already know. So for whatever number you take, whatever natural number you take, if you take a set of n plus 1 numbers, if you take this set, okay, if you take a set of n plus 1 numbers, then at least two of them will give you same remainder. Okay, at least two of them will give you same remainder. So here also two of them will give you same remainder. Okay, take any two. Let's assume that this and this. Assume this and this. Okay, the point is, whichever two, you guarantee that two of them will there exist a comma b here. Okay, such that a mod 9 equal to b mod 9. Agree? They will give you same remainder. Now, all you just need to do is just do a minus b. Find a minus b. Tell me, if you find a minus b, what digits it will contain? Find a minus b. What digits it will contain? From this, if you remove this, or for example, from this, if you remove this, only 1, 0 it will contain, right? That's it. That's your point. That's the proof. So very simple. I am saying that from these, you take, there exists a comma b. There exists a comma b such that a comma b will give you same remainder when you divide by 9. Okay, such that. Now you already know this simply means, 9 divides a minus b. 9 divides a minus b. And you know that a minus b contains only 0, 1. Contains only 0, 1. Is this proof clear? Please tell me. Is the proof clear? The same proof you can do for any n. for any n, whatever n you take, the same proof you can do. Tell me what you will do. Whatever n you take, what set you will consider? Tell me what set you will consider. For any n, whatever n you take, consider this set. Okay, consider this set. This set you consider 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Consider this set. How many? Finally, I can say 9 n plus 1 ones. N plus 1 ones. Is this clear? So how many you have? So you have total n plus 1 numbers you have. You have total n plus 1 numbers. Agree with me? See, whatever number you take, whatever n you take, for any n, what you do? You consider this set. In this set, you have total n plus 1 numbers. N plus 1 numbers. Now, definitely two of them will, what will happen? What will happen? Tell me. Definitely what will happen? There exists a comma b. Here in this list, there exists a comma b such that a is congruent to b mod n. They will give you same remainder when you divide by n. Okay, so this is what I am saying. I am saying that definitely there exists a comma b such that a comma b will give you same remainder when you divide by n. And that means n divides a minus b. N divides a minus b. And you tell me, from this, if I remove this, the number I will get, that will contain 1, 0, right? What a comma b, what a minus b will be? A minus b. For example, from this, if I remove this, then I will get number which contains only 1, 0. I will get a number which contains only 1, 0. So you can easily notice that a minus b contains only 0, 1s. Okay, is this point clear? Let me know, is this point clear? Please tell me. Did you understand this? Okay, I hope all these points are clear. So this proof is clear. Finally, is this proof clear? The proof is clear or not? Did you understand? So this is the conclusion. This is the conclusion that for all n, for all positive integers, for all n, there is a multiple. There is a multiple of n. There is a multiple of n which contains only 1, 0s. Which contains only 1, 0s. Okay, is this clear? Please tell me, is this point clear? So for any n, whatever n you take, for any n, there is a multiple. There is a multiple of n which contains only 1, 0s. It will only contain 1, 0s. I hope this point is clear. Now, one more actually interesting thing, if you notice, from this proof, you tell me, can I say there is a multiple? Can I say there is a multiple which contains only 1, 0s where ones are followed by zeros? Where all ones are followed by all zeros? Where all ones are followed by all zeros? Can I say this? How can you prove it? See what I'm saying. This additional point I'm saying, which contains 1, 0, where all ones are followed by all zeros. What it means? It means what I want to say. I want to say that whatever n you take, this n will divide this type of number. N divides this type of number 1, 1, 1, 1 and then 0, 0, 0, 0. N divides this type of number. This type of number. Can you prove it? Please tell me, can you prove it? From the previous proof, can you prove it? N divides this type of number. Whatever n you take, that will divide this type of number. Can you prove it? How to prove it? Tell me. How to prove it? Tell me. See, very simple proof. You know that for a whatever n, what you will take? Again, you will consider the same set. You will consider this set 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and so on. And so on. N plus 1 ones. So total how many? Total n plus 1 numbers are there. Right? Yes or no? Total n plus 1 numbers are there. Definitely two of them will give you same remainder. Agree with me? Agree with me? Two of them will give you same remainder. Okay. At least two will give me same remainder. At least two. At least two of them give same remainder when divided by n. Give same remainder when divided by n. Okay. Yes or no? At least two of them will give you same remainder when you divide by n. What are these two? What are these two? For example, let's assume these two. Let's assume these two means let's assume a comma b. Let's assume a is something like this and b is something like this. Okay, let's assume these are assume they are giving same remainder. Assume they give same remainder. Okay, assume they give same remainder. Now you tell me. Assume they give same remainder. Now you tell me. Now you just check b minus a. Now just find b minus a. What is b minus a? Tell me. Find b minus a. Tell me how b minus a will look like. Tell me how b minus a will look like. It is like this. From this type of number, if you remove this type of number, what it will look like? It will look like 0, 0, 1, 1. It will look like something like this. B minus a, that will something like this. Agree? It will look like this. B minus a looks like this. Looks like this. So that's it. This is your proof. This is your proof. So understood? 0 followed by a. 0 followed by a. Who is followed by whom? 0 followed by 1 or 1 followed by 0? Here, who is following whom? Here 0. Sorry, here 1 followed by 0. Oh, here 1 is followed by 0. Okay. 1 is followed by 0. Where all the ones 1 are followed by, yeah, this is correct. Okay, I've written correct. I have written the correct statement, right? Where ones are followed by 0. Yes, ones are followed by 0. Here also you can notice these ones, these are followed by 0. Ones are followed by 0. Okay, so this is the final thing. This is the final conclusion. So this conclusion, if you want, you can remember. What are the conclusion? This is the conclusion that for all n, which is a positive integer, there is a multiple of n. There is a multiple of n which has the form this type of form, right? Yes or no? Which has the form, this type of form. This is the answer. This is the conclusion. Okay, I hope this point is clear. Simple. Now I'm asking one question. This question is from Grimaldi book. This question is taken from Grimaldi book. How will you prove it? I'm asking this question. This is from book Grimaldi, exercise 5.5. How will you prove it? Question is saying that for any positive integer, there exists a positive integer such that k divides n and only digits are 0, 3s. How will you prove it? Basically, this question is saying that basically this Grimaldi question, what this Grimaldi question is saying? This question is like this, that for all whatever k you take, whatever positive integer k you take, this question is saying that k divides, or I can say there is a multiple of k. Okay, see, whatever k you take, there is some n. There is some n such that n is multiple of k, such that k divides n, and this n contains only 0,3s. This n contains only 0,3s. How will you prove it? How will you prove it? Now, can you see the proof is very easy? Whatever k you take, for any k, what you will take? You will consider these. For any k, you just consider 3, 3, 3, 3, 3, 3, and so on. K plus 1 times. K plus 1 threes. Yes or no? How many numbers I have taken? I have taken k plus 1 numbers I have taken. I have taken k plus 1 numbers. Okay. In these k plus 1 numbers, what will happen? In these k plus 1 number, what will happen? At least 2 will give me same remainder. At least 2. A comma B give same remainder. Give same remainder when divided by k. Yes or no? They will give same remainder when you divide by k. Correct? Agree? Now, what you will do? Now, just find. So, this a comma b, this something, for example, a is something like this, and b is something like this. Okay, a is something like this, b is something like this, and they give same remainder when you divide by k. When you divide by k, they give same remainder. This simply means k divides a minus b. Or I can say this simply means k divides b minus a. A divides b, k divides b minus a, right? Okay, and what is b minus a? What b minus a will look like? B minus a will something look like this. 3, 3, 3, 3, followed by 0, 0, 0, 0. 3, 3, 3, 3, followed by 0, 0, 0, 0. Understood? Please tell me. Did you understand? So, what I can give you, what conclusion can I give you? Can you notice? Another conclusion I can give you that for all n belonging to positive integers, for every positive integer, there is some multiple of n. There is some multiple of n which looks like what? Tell me. There is some multiple of n which looks like this. 3, 3, 3, 3, followed by 0, 0, 0, 0. Which looks like this. Okay. Can you notice the same statement? Now I can say for anything. Here 3, 0. Can I say the same statement? Can I say for 9, zeros? Can I say the same statement for 8, zeros? Okay. Is this clear? Please tell me. So that's it. That's it. Whatever positive integer you take, any positive integer you take, any positive integer, this n can be 99, 999, this can be 1 crore, this can be whatever a positive integer you take, there is some multiple which will look like this. There is some multiple which will look like this. There is some multiple which will look like this. Can you see this is a cool theorem? Now, do you agree with me that this is a cool theorem? Is there anyone who is finding this theorem cool? And the proof is also very simple, extremely simple. And this Grimaldi question is also there. We have solved it. This Grimaldi question, 0,3s. 0,3s. Of course, the same question you can say 0,7s. That is also correct, right? If I say 0,7s, that is also correct. That is also correct. If I say 0,4s, that is also correct. Is this clear? Please tell me. This is your pigeonhole principle. We have seen everything. One thing I can tell you that we have seen everything. From the GATE exam point of view, whatever you need, we have seen everything. In future also, whatever question will come from the pigeonhole principle, most probably we have seen that already. We have seen all the variations. We have seen the complete analysis. We have seen all the gate relevant standard questions, all the gate questions, all the TIFR questions. Okay. Kenneth Rosen questions, Grimaldi questions, some cool theorems. So everything we have seen. Please tell me, did you understand this pigeonhole principle? The complete coverage of pigeonhole principle, did you understand? Everything I have told you, let me tell you. In these lectures, whatever we have seen, in our pigeonhole principle lectures, whatever we have seen, that is much more than enough. Okay? You don't have to worry about anything else. Our lectures contain entire coverage of pigeonhole principle. Please tell me, did you understand, and are you confident in pigeonhole principle? And did you understand this theorem? This theorem, did you understand? Please tell me. Like this question. Anyone has any doubt in this question or this type of question? This question or this type of question? Anyone has any doubt? Please tell me. So this is just, I can say this is just a cool result. Okay, you can call it a cool result. Okay. Okay, so thank you everyone. Everything is covered. That's it. So see you tomorrow. And tomorrow we will solve the remaining questions of recurrence relation practice set, right? Recurrence relation practice set I gave you. Some questions we have already discussed. The remaining questions we will discuss tomorrow. Okay? Recurrence relation practice set. The remaining questions we are going to discuss tomorrow. Okay, thank you everyone. Thank you so much.